This segment will cover demonstrating the PowerProbe 4 and Maestro's features on the new demo board. Now, as good as the PowerProbe 3s are, and as much as you can accomplish with a PowerProbe 3 or a PowerProbe 3 EZ, imagine if you had more of those multimeter functions packed into your PowerProbe. That's what you're getting with both the PowerProbe 4 and the PowerProbe Maestro. There's some differences we'll point out, but they both include a lot more multimeter functions beside the basic DC voltage of the PowerProbe 3s. So you have DC voltage. They have two different AC voltage modes, AC RMS and AC peak to peak. The AC peak to peak is similar to the peak to peak mode in the PowerProbe 3s, and AC RMS reads more like a traditional multimeter would. You have a resistance mode. It's called feed test. So you can measure resistance in ohms, and it has some unique testing features we'll show you. There are multimeter modes for reading things like frequency, duty cycle, pulse width in milliseconds. They both include a fuel injector test mode. It's pretty impressive on the demonstration. And some other features that will show specifically the differences. But a PowerProbe with more multimeter functions, and let's get into showing them off. Let's look at the PowerProbe 4. Slightly bigger than the PowerProbe 3, much nicer display. You'll see multiple pieces of information on the display in each mode. For example, let me turn the speaker off. You'll see voltage, min and max already on the bottom in your VDC mode. Those aren't separate modes like they are in the PP3 or the PP3 EZ. Now, you have three buttons here. This one is your mute button. So if you like the tone or you don't like the tone, you can have that on. This one is your mode select button. It'll bring up the menu. This one is the clear button for readings like min max. And I believe there's selector buttons too. So you use these arrows indicate either up or down. It'll scroll through this list of different testing modes you have. You have voltage DC mode. I'm going to skip down a couple. You have AC RMS, which reads like a traditional multimeter, and AC peak to peak, which reads more like the PowerProbe 3s, a true peak to peak reading. You have a mode for frequency and pulse width. In the PowerProbe 4, there is a fuel injector mode. This mode works together with the PowerProbe short and open finder, the ECT tools. This mode allows you to safely test computer driver circuits. And we're back to voltage DC mode. So it'll scroll around. You'll just come back around to the beginning again, either direction you're using to scroll around. Your DC mode. Right away you can see speaker off. It'll display when I'm applying power, when I'm applying ground. You have the red lights and tones that work exactly, and green lights like on the normal PowerProbes. And you have min-max readings already at the bottom of the display. So any variations in voltage, you'll be able to see it right there, unless you clear. And then you're in variation from that point. Pretty simple. That's a lot like all the PowerProbes. Let's go to ACRMS, and you'll be able to use your AC frequency modes to illustrate the readings here. Let's turn it on. So ACRMS will average the voltage. So for example, this is a 5-volt pulse. If it averages, yep, but it displays 2.5 volts, which makes sense because this signal is on half the time and off half the time. So half the time it's 0, half the time it's 5. Half of 5 is 2.5 volts. But if I want to know a true peak-to-peak reading, I would select AC peak-to-peak mode and know that I'm getting a 5-volt pulse. This is kind of unique. Most of your multimeters are going to read like AC RMS. It can read different voltages. And that was RMS. Let's go to peak to peak. So 8-volt peak to peak. And you can see it captures min and max voltage at the bottom. Again, just like in the DC voltage mode. And since we're on the AC stuff, hertz frequency. It will show you the frequency in hertz and the either positive or negative time that the signal is either positive or negative. So that's what they're called pulse width in milliseconds. You can read different frequencies up to 10,000 hertz, or 9999 is the maximum on this tool. That's fast enough for most sensors on cars though. And since I have it on, let's go to fuel injector mode. This will display 4 pieces of information. You've got on time, how much time that injector is actually squirting. You have the ground from the ECM or computer driving that fuel injector. This is the supply voltage through the windings of the injector. This last number here is called inductive kick voltage. It's usually a big number in the 60 to 80 range. More important than the number, it should be consistent across a car's set of fuel injectors. If the windings are beginning to short out, that number will drop off. So let's see. Normally you would use, and all these tools are 4mm banana jack, and you can use an extension lead with a back probe adapter to actually probe in like you would on a car. But we've got a little test point here. I'll turn that speaker off, but you've got Noid light action here. Every time that blinks, that means that injector is firing. You heard the speaker that will go along with it. And the 4 readings I'm talking about, on time. We're almost 6 milliseconds here. My ground's good, almost a perfect 0. My supply voltage is good. And my inductive kick is running a steady 65 volts. Real quickly, you can run down a row of fuel injectors, compare readings. If one's odd, chances are that that's your problem injector, if you have a single cylinder misfire or something like that. What did we skip? We'll come back around to feed test. Feed test is your ohm meter mode. Now, one thing you'll know, even though I'm in a resistance mode, you'll see it has battery and tip voltage at the displayed at the bottom. With a normal meter, ohm meter, you do not want any voltage on the circuit that you're checking resistance. At the least, it'll affect your readings. It could damage your meter. Now, this one can be used. There's a ground lead on all the power probes. Where are you? To read resistance directly, just like you would with a normal ohm meter. A normal ohm meter, you would have 2 leads. You'll put the tip on one side of your resistance, the ground lead on the other, and get your resistance reading. That's normal, just like a normal ohm meter. What is not normal is I can tap into a live circuit with voltage on it, and it'll indicate if positive if I'm on the positive side of the circuit, green light negative if I'm on the negative side of the circuit. But the resistance reading, you're seeing right now is 0, is from battery positive to wherever I am in the circuit. So even in a live circuit, I can tell if there's too much resistance or not. Anything over 10 ohms, you don't get that light. That's telling you there's a problem there. Now I can also see battery and tip voltage at the bottom of the display. Now this is important to illustrate loaded voltage. There's a difference. This is unloaded, and that is an accurate measurement of the resistance in that circuit. Now in a loaded circuit, meaning the lamps are on and there's actually current flowing through the circuit, now unlike before, you'll see a difference in the reading between battery and tip voltage. Watch, unloaded, no difference, even though there's resistance, until current begins to flow. That's what creates the voltage drop. So feed test can be used to check resistance like a normal ohm meter. It can check static resistance in an unloaded circuit, and it can check active voltage drop at the bottom of the screen in a loaded active circuit.